I end up getting a negative coefficient up front, and I still got my sign change. But I think down here, that's going to give me a lambda squared plus 2 lambda. Actually, minus 3. So I'm sorry for my arithmetic. And that's finally going to leave me with a lambda plus 1 times lambda minus 3 twice. Okay, barring any silly arithmetic errors, I've come up with my eigenvalues. Let's find the corresponding eigenvectors. I think for my first lambda value, lambda sub 1 being equal to -1, let's crank it out. I think the corresponding eigenvectors generated by subtracting this lambda off the main diagonal. But isn't that going to give me a 2, 2, 0, 2, 2, 0, and then a 0, 4, 4, and it's augmented with zeros. So 1, 1, 0, 0, and then a 0, 0, hold on, 0, 1, 1, 0. 0's everywhere else. And maybe finally, does that give me a 1, 0, negative 1, 0, 0, 1, 1, 0, and then all the rest are zeros? And you guys, if my arithmetic is correct, let's talk about the first eigenvector. I think V1 bar is going to be, oh, I don't know, you guys. Would that be a 1, a -1, and a 1? It's a couple nods. I hope the rest of you haven't given up. Yes, I was just lazy to watch. I said, this equation right here looks like an x sub 1 minus x sub 3 equals 0. Second row says x2 plus x sub 3 is equal to 0. And I left, in my head, x sub 3 being equal to t. But doesn't that imply x sub 2 is negative t? And doesn't the first equation tell me x sub 1 is positive t? And so I think my x1, x2, x3 as a column vector is simply going to be t, negative t, and t. I just gave up, and I chose in my head a specific value t. And that's where I got my 1, -1, 1. But like I said, you bugged me for just giving too much. My technology, you guys, doesn't want to play. There we go. Oh, thank you. I had the lucky touch that time.
Don't worry, Mr. Dog Guy. It'll be gone by the next time.
Thank you very much. I appreciate that.
No one has the lucky touch.
So you guys, can I actually list the corresponding solution to the VPE? So I guess, can I erase this? I guess in the end what that really means is that my first solution, my x1 bar t, is going to be equal to my first vector v1 bar, which really is an eigenvector. Corresponding eigenvalue of -1. I'll circle in case I forget where it is. Now I think when it comes to the other eigenvalue, lambda being equal to +3, can I label this lambda sub 2? To find the corresponding eigenvectors, potentially plural. I'll subtract the remainder down the main diagonal like I typically do when I try to find corresponding eigenvectors to eigenvalues. And I think that's going to give me -2, 2, 0, 0. Is that going to be a 2, -2? 0, 0. And then finally a 0, 4. Is that a 0? But this is going to reduce down to the following. Or shall I say this?
What?
Oh, you didn't like that.
Oh no. Okay, I see. You changed your rows. All right.
I did.
Yeah.
Isn't that a problem?
What's that?
Is there a problem? Because you don't have a V3?
Quite the contrary. The fact that I have a 1 here and here means
You have
If I
two
don't it in this-
zeros.
This last column, it better be a zero downstairs, otherwise I wouldn't have a free variable.
You have 2 zeros and whatever you want.
So I think a corresponding, how about V2 bar? Could be equal to, um,
0, 0, anything.
thank you. And how about saying this? Correspondingly, x2 bar t is equal to, well, I guess it's just a V2 bar, which is 0, 0, 1, times e to the lambda t, where lambda was 3, thank you. And we are done, because the solution to VDE is, what's that? You know what, he's right, I'm not done. This is a 3 by 3 matrix. And I only came up with 2 linearly independent eigenvectors. That means the matrix is defective. I can't stop. So here's what I'm going to do. I'm going to, for a third solution, I've got circle 2. For my third solution, I will allow x of bar 3 of t to be equal to nothing more than, oh shoot, would that give me a, you guys help me with this, is that a v3 bar plus tv4 bar?
Yep.
Times e to the negative t?
No.
No one.
No, it wouldn't be.
What's wrong?
Wouldn't you want to do a
How do
V3?
you know?
Huh?
How do you know?
Go ahead, did the homework.
Okay, you did the homework.
Yeah.
I was hoping you say this.
All right.
When it comes to the lambda value of negative 1, notice how that was algebraically the zero of a linear factor raised to only the first power. It had multiplicity 1.
Yeah.
It's really the other eigenvalue that had multiplicity 2, but I only found one corresponding eigenvector. Did you guys see my point? So I think I made my wrong choice with the coefficient of t upstairs. I really think for that reason, this should be a 3t. It is 3, isn't it?
Because it's your eigenvalue plus.
Because for this particular eigenvalue, I only generated one eigenvector, but it has multiplicity 2, algebraically speaking, in the expansion of the characteristic polynomial. You guys, for the sake of time with the clock, okay, I'll finish this question, I really will. Can we just pretend for a minute that was the only eigenvector? Excuse me, I missed it though. Can we just pretend that's the only eigenvalue?
No.
And let's suppose it had multiplicity 3.
So why are you using V3 and V4 here?
What
Didn't you call V2 as your first term that's being multiplied by e to the 3t?
Yes.
So wouldn't you want a V2 in there?
Good
Rather
point.
than-
It'll end up being the same as V2.
Okay.
Sometimes I don't allow it to be, sometimes I allow it to be something different.
Okay.
I think today, I just decided once I started lecture, since we did a little bit of homework, I wasn't going to do that. But
Okay.
typically it could be something different.
All right.
The way I'm going to play the game, it'll be the same though,
All
which
right.
you will see. You guys, check this out. Because I'm running against the clock, can we just pretend for a minute that lambda minus 3 was being cubed? There was no other factor. Therefore, this is my first only solution. Here will be my second. Let me show you to get my third. My third will be x of 4 bar t being equal to a v sub 5 bar plus t times v6 bar plus t squared over 2 factorial times v7 bar t times e to the 3t.
If I had multiplicity of 4, then it would end with a t cubed over 3 factorial.
Perfectly put. Now, I know I wasn't consistent with my notation, but you have to confess, this is equivalent to t over 1 factorial. And this is equivalent to being multiplied by t to 0 over 0 factorial. So it is consistent, even though I didn't write it that way. Yes,
So
Chris?
the way you generate these solutions, we have multiplicity or like multiple eigenvalues that are the same.
Yeah, that's why I'm saying, if I really just had the one eigenvalue of 3, in other words, lambda minus 3 raised to the 3rd power, all the eigenvalues in a sense, if you're going to put it that way in English, are the same.
So
I just
this,
say I only have one eigenvalue.
this really is where Taylor series
Giving us
goes.
like a 3 by 3 matrix, should we expect 3 eigenvalues that we resolve?
Well, look at this example, I only generated 2 of them.
Yeah, but like 3 total including the multiplicity of 3, right?
Oh, if you're going to put it that way, then it's always the case, yes. If you're going to include algebraic duplicity, it'll always be equal to that number n. That's true. It's just that the geometric duplicity was different. I kind of like to refer to that as geometric duplicity because I'm generating an eigenspace.
So
Yes.
Well, this is really starting to look like Taylor series.
Of course it is.
And so, say that you had nth term or something that you were trying to find. How would you set that up?
Then this would be a t to the n minus 1 over n minus 1 factorial
Okay.
times v sub whatever bar,
Okay.
in all the terms preceding it.
All right.
Well, everybody, I'm almost done. I think this is my last solution I'm going to generate. Then I'll look at all linear combinations. And I need to pick this up and substitute back into the original vector differential equation. And I think what that gives me is, hold it, I can't do it. I said back in the original VDE, the left-hand side I've got to differentiate. Well, here's the first times through the second. Plus the second times through the first. Being equal to, well, my a times my x of r sub 3. And yet again, equating things like, how about equating coefficients of t? I think what this tells me is that 3 times v sub 4 bar is equal to a times v sub 4 bar. Shoot, you guys, by definition, that simply means that v sub 4 bar is going to be a corresponding eigenvector to the eigenvalue of positive 3. And you know what? I think I've already generated one. It's 0, 0, 1. So I will choose v sub 4 bar to be equal to nothing more than that. Now what I need to do is generate what v sub 3 bar looks like. I'll be done. Now to find v sub 3 bar, I'm going to not equate coefficients of t, but I will equate constant terms. And equating constant terms, I think that leaves me with, shoot, you guys, the left-hand side suppressing the exponential factor. I think equating constant terms, that gives me a 3v3 bar. Is that plus a v4 bar? Being equal to the constant term on the right-hand side of the equal sign, but that's just an av3 bar. Doesn't that tell me that a minus 3 times I times my v3 bar is equal to my v4 bar? Well then, subtracting 3 off my main diagonal, I think that gives me this. On the left-hand side, a negative 2, 2, 0, I think, hold on. I said 3 off the main diagonal. I like it. How about 2, negative 2, 0? And then finally, is that a 0, 4, 0? I'm in with the zeros.
No.
No, I'm in with a
D4.
which I found to be 0, 0, 1. And let's play to reduce. And in reducing, I see I have a 1, negative 1, 0, 0. 0, 1, 0, 1 quarter. And zeros throughout here. That gives me this. What's the first line? Is that going to be positive 1 quarter? Well, let's rewrite, see what that really says. If I let the v3 bar to have these components, how about v1, v2, and v3? Then I think these equations tell me the following. That v1 is equal to 1 quarter, and v2 is equal to 1 quarter, and v3 is equal to
Whatever.
yeah, whatever. And so, I think my v3 bar is equal to a 1 quarter, 1 quarter. 0. So, finally, I see my x of 3 bar t is equal to, sorry guys, I really don't remember. Was that a v3 bar? plus a t times v4 bar, which was one of my eigenvectors. You guys, can you separate from my plus and t's? Sorry. That's a plus t times. And I'm being multiplied by e to the, remember, it's 3t. So, I guess putting things together, that means the following. I think you guys, in the end, all solutions are going to be of this form. C1 times x1 bar plus C2 times the next plus C3 times the next. Or shall I say, in this particular example, is that C1 times, do you guys want if you just put B at all? Is that okay? You factor out all.
Can you?
Yeah, I guess I can't do it this time. You guys are all different.
Yeah.
They're not all different, but some are different. I guess I'm kind of
You
stuck
could
on this
maybe
now by brute
Group them
force.
together or something.
Yeah, I suppose I could
Yeah.
do that. Is that a 1, -1, 1? I think times e to the negative t. Hold on. Yes, I'm correct. Plus some stuff. How about some stuff times e to 3t? And here's what the other stuff really is. So C2, 0, 0, 1. Plus C3 times 1/4, 1/4, and a t. Is that right? Ah, very infinite collection of solutions. Do you guys think I should bore you with the finding coefficients C1, C2, C3? Do you think I should bore you with finding coefficients C1, C2?
That's just initial value.
True, but I think I should wait until we hit applications.
Good.
Could be tomorrow.
I have a question. So, when you're trying to find V2 with your eigenvalues 3 over here,
Yes.
after you reduce your matrix to the bottom and you have V2 is equal to 0, 0, 1. Right?
Yes.
On the other side, you augment that matrix over there, and you get a similar V2 matrix with zeros on the bottom.
Yes. Well, think about it. The left-hand side over here is generated in exactly the same fashion.
Yeah, yeah. So how come your V bar from that side, see over here you have a 1 on the bottom, but over there you have a 0 on the bottom. Can you explain why there wouldn't be a 1 on the bottom, 1 on the right?
It's really because everything got messed up with not having a 0 on the right-hand side over here. The fact that this is not equal to 0 means I guess it's completely different.
So that started as a 0.
True, but you know if this was 0, what that really means is that you found your v sub 4 bar to be the 0 vector, but shoot, that's not going to happen because that's going to be a non-zero eigenvector.
I'm just confused as to why for this one you let x 3 be anything, and then over here.
Louis, you said x of 3.
For that matrix.
Oh, down here.
Yeah, down there. See how it's all zeros, and then for the V2 bar you have 0, 0, 1. And then on the matrix over there, you have a similar looking situation, but for the vector you use 1.14, 0.
Could you have chosen a 1 for the third component of
That's what
V3?
I'm wondering. Yeah.
You could have chosen any value for the third component of V3 and you just chose you just chose 0.
So over here, if I think of the V2 bar, before I find it, oh, excuse me, I said V2 bar, to be equal to this. I do think the very first row of this augmented matrix tells me this. The second row tells me the same thing. It's just the third row says x of 3 could be anything. And that's how I generated this corresponding black eigenvector that I labeled as V2 bar. It's just that over here, since I was augmenting with 0, 0, 1, if you take a peek at what this really says in terms of in this case, V1s, V2s, and V3s, you know what, Chris? I think you've got a good point. Maybe I'm just running too fast. Maybe I'm just too tired to look at my details. I think in equation form, that looks fine. That looks fine, but you're right, using the same logic, I think, got this. Can I call it K? It's just that I want to find one of these eigenvectors in V3 bar, just one of them. So if I allow K to be, I don't know, let K be anything so that I don't get the zero vector. I'll let K be equal to 0. I think it works. I don't think I could have done that over here, because if I chose my T to be equal to 0, then that really means I've got the 0 vector as an eigenvector. By the way, something else, I really shouldn't have used the letter T, should I? I mean, that's my independent variable. Can I change it? But good point. I just chose a particular value to make it work. And that means when you solve this DE or this VDE, you could have chosen anything in normal T's for that K. But I maintain if you do, in the end, you're going to generate all the other solutions as T ranges over values. It's not going to make any difference.
So if we really wanted to make grading interesting, we could maybe throw some
You wanna
integrals
make
in
me
there.
I mean,
42
give
would
up.
be a good answer. Right?
You know what I do great, that's what I tend to do though, is I
Yeah.
just look at linear combinations.
Okay.
To make sure your answer is the same as mine.
Okay.
That generates the same solutions. Hey guys, two examples, and one full hour.
Yeah, that kind of covers the bulk of it, though.
So what else am I missing, you guys? VDEs. What else am I missing? How about the big guns? The non-homogeneous case of the VDE. So I think what you and I need to tackle next time is solving a DE like this. And I know it sounds confusing, but my technique, which actually I thought I might be able to start today, my technique is something I tend to refer to as variation of parameters, but it's variation of parameters on a VDE, not a higher order DE. So our approach is going to be different. But there are some similarities. Yes.
When you're trying to find the V3 bar and V4 bar, and you're saying that you're substituting back into the original VDE,
Yes, I am. That's how I generated this relationship right here.
are you substituting back that x bar prime equals x bar?
Yes, that's exactly what I meant. So when I wrote this thing in this big block, blue box, that was the result of taking this x sub 3 bar and substituting back into this VDE. That's where that blue box came from. Can you appreciate how much work there was? We had a lot of work, but notice how on the left-hand side of the equal sign, there's multiple terms, because to differentiate that, I'd have to use a product formula. Because that left-hand side really is supposed to be x bar prime. Thank you. Guys, anybody else want to tackle me on this before I leave it alone?
I said, when we chose V sub 4 bar, but you chose it to use that vector because it's already eigenvector.
Yeah.
So you just,
I'll be honest with you, I feel a little rushed. I never do this. I will typically come to class and refer to as 0, 0, R. Then I can plug it in over here, and I can avoid fractions at the end. I just felt kind of pushed since I took some time on the homework. But typically that's what I do, and that's why when Brad brought the issue up, he said, well, no, shouldn't you call it V2 bar? I don't bother doing that because it could be different. It could be a different eigenvector. Yes?
Sorry, a minus 3i represents the eigenvalue of 3, right?
Yeah, but you see where that came from the previous equation? I wasn't concentrating what the eigenvalue and eigenvectors were. All I was doing is this, I was being this lazy. I said, bring all the V3 bars together. I get this. From the previous line. Then I referred to the second term as this. Then I factored out the V3 bar, and then switched sides. So I think this came from factoring out a V3 bar from the right-hand side up there. And then I realized, oh, that's kind of nice, because 3 was my eigenvalue.
So you don't mind, too, if we just use the books method?
Absolutely not.
'Cause I'm kind of just used to that at this point, even though this seems like it might
just
be
think
more
it's complicated.
practical. Yeah.
Opinion.
Where does that pattern come from that we do, like, T to the n minus 1 over n minus 1 vector?
That comes from a detailed poems. Do
So,
you remember all like this?
yeah, it's just, so we're trying to find a new,
So when you differentiate and go backwards, when you start differentiating, you finally just end up with those corresponding vectors with DI bars. And all the coefficients drop out through the differentiation process.
So I've got the homework you gave us last week written down.
Oh, thank
If
you. What is it? Can you
It's
read
just 7.5, 1 through
So
15
section
odd.
7.5, number
1 through 15 odd.
1 through 15 on. So I will now officially sign it. So on the, out of the book, Chris, I'm stalling, I don't remember. And you guys,